do a video on how to use the distribution of multiplication over addition, also known as the distributive property. And I am going to go fast, so if you need to pause, please do so. But I'm going to do, it looks like 7, 8, 9, I think about 10 examples. And the first two, all I'm going to do is, what does this mean? Well, we know what 3 times 2 means. 3 times 2 means I have 3 groups of 2. 1, 2, 3. And therefore, it's 6. That's all it means. All right, so let's take a look at what it would mean if I had 3 groups of x plus 2. What I really have is x plus 2. That's one group. There's another group. And there's a third group. So now I have, you can see quite easily, I have 3 x's. And I have 1, 2, 3, 4, 5, 6. I have 6. So 3 times x plus 2 means I have 3 groups of x plus 2. Or 3x plus 6. Now, a lot of students will try to add 3x and 6 and say, oh, I have 9. But that's not true because you have 3 x's, and we don't know what x is. It's a variable. It could be any number at this point in time. I'm going to use another way of showing this. And now I have 2 groups of 3x minus 1. So if I had one group of 3x minus 1, and now I have another group of 3x minus 1. And once again, you can see that altogether I have 6 x's minus 2. And that's quite literally what the distributive property is saying. How many groups of something do you have? And then just count them up. It's just multiplication. So what does this look like when we're doing it? Because you probably don't want to be drawing pictures the entire day. Well, that's understandable. So this says I have 3 times x. I have 3 x's. And I have 3 times 5, which is 3x plus 15. And that's all that is. Now, the next one, I kind of wish I hadn't drawn that line there. The next one's going to look like this. I'm going to use this yellow here. Now I have negative 3 times x, so it becomes negative 3x plus negative 3 times 5, which is negative 3x minus 15. And I'm going to show you what I like to call my pro tip, which really isn't a pro tip at all, especially if I can't seem to actually gather it. So take a look at this. If I bring this on over, let's see if I, well, maybe I'll just bring my page on over. Here we go. Bring this on over, move my page back. It says, pro tip, look at the signs of each term in the parentheses. If you're multiplying by a positive number, which we were here, we're multiplying by a positive number, then the signs will stay the same. This was a positive x, even though there's nothing written there. It's a positive x, and this is a positive 5. And take a look. I have a positive 3x and a positive 15. But then it says, if you are multiplying by a negative number, the signs of each term will be negated. So here now I'm multiplying by a negative 3. I had a positive x and a positive 5. So now I end up with a negative variable term and a negative constant because it was positive positive, now it becomes negative negative. So basically, if you're multiplying by a positive number, your signs will stay the same. Positive positive, sure enough, my answer was positive positive. If you're multiplying by a negative number, which I was, my positive positive is going to become a, oh, I went to my negative 3x. It's going to become a negative and a negative. So that's a little pro tip. You can take a look and see what your signs are going to be even before you get started. All right, so letter C, I'm going to do letter C over here. It says 2 times 3x minus 2. It's a positive and a negative. My 2 is positive, so I'm going to have a 2 times 3x plus a 2 times a negative 2, which is going to be 6x minus 4. And that makes sense because, look, this was a positive 2. I have a positive value and a negative value. I have a positive variable term and a negative constant. Letter D. And once again, if I'm going too fast, please pause the video. All right, so I'm going to take a quick look. It looks like I am multiplying three terms by -4. All right, I have a positive, a negative, and a positive. So my answer should be, because I'm multiplying by a negative, my answer should be a negative, a positive, and a negative. So let's see what happens. I have a -4 times 3a plus a -4 times a -5b plus a -4 times a positive 2c. So let's see. 4 times 3 is 12. -4 times 3 is -12. -4 times 3a is a -12a. 4 times 5 is 20. -4 times a -5 would be a positive 20. So it's going to be a positive 20b. Then I have a -4 times 2 is a -8. So it's going to become a -8c. And once again, sure enough, I have three terms. Negative, positive, negative. I don't know where that triangle came from. All right. My last example is I'm multiplying by a positive, but I have a negative and a negative, so my answer should be a negative and negative. I'm going to have 1/2 of -4y plus 1/2 of -6y. Well, 1/2 of 4 is 2. So 1/2 of -4 would be -2, and it's a 4y, so it's going to be -2y. 1/2 of -6y is going to be -3y. And sure enough, my answers start negative and they end negative. So, once again, if I'm going too fast, please feel free to slow down, pause the video, and do it your own way. So why is this useful? I'm going to take a look at 18 times 15. Or maybe I'll do 15 times 18 first. I don't know what 15 times 18 is, and I've forgotten my calculator. So I'm going to do this. I'm going to change this question into a different question. I'm going to change this question into 15 times 20 minus 2. And the reason why is because I know that I can multiply those numbers. So what's... Oh my goodness, my screen's running away from me. What's 15 times 20? Plus 15 times a -2. Remember, 20 minus 2 is 18. So now I have 15, well, I know that 15 times 2 is 30, so this must be 300. 15 times 2 is 30, so that must be -30. Oh, well, 300 minus 30 is 270. So I can use the distributive property to multiply. And not only that, take a look at this. I don't even have to do it that way. I could say, well, what's 18 times 15? It's the same question, but this time I'm going to change it into 18 times 10 plus 5. So I get 18 times 10 plus 18 times 5. Well, 18 times 10 is 180. That's 100. That's 100. Why is my pen not working now? That's 180 plus, well, if 18 times 10 is 180, 18 times 5 has to be half of that, so that's going to be 90, which is, once again, it's 270. So the distributive property is actually really, really useful when you're multiplying numbers. And I had one other one, which is basically just something that you guys may or may not realize you do all the time. Use this when you cook, well, although maybe you don't cook, so perhaps you don't use this. But the other day, my kid was making waffles, and here's the recipe: 2 cups flour, 1 1/3 cup milk, and remember, 1 1/3 is really equal to 4/3, and 2 eggs. So she wanted to half her recipe, so 1/2, 2 cups of flour, plus 4/3 cups milk, plus 2 eggs. Well, when we distribute that, it's going to be 1/2 of 2f plus 1/2 of 4/3 plus 1/2 of 2 eggs, which means she needed 1 cup of flour plus half of 4/3 is really 2/3. 2/3 cup of milk plus half of 2 eggs is 1 egg. And so that's it. That's the distributive property in a nutshell. Here is really math-wise what you need to know. Part 1 and part 3 were to kind of give a little bit of explanation as to why and how. But remember, all you're really doing is multiplying this number with each term, and that's it. All right? Good luck.